Hey guys, how's it going? So just moving along in our Math 30 course over here. If you're in my class, guys, this is the last chapter that we're doing in this course, rational functions. And I think it's a very kind of straightforward chapter to kind of finish off towards the end of the course over here. And so we're just going to learn about a different type of function, a function that we actually have studied already a bit this year so far. And you would have done a bit of this one in Math 20 as well. And we're going to be kind of applying transformations to these type of functions over here. So for the first slide over here, we have this graph of f of x equals 1 over x. Okay, so just a quick little table of values on how this function works. All right, so if we have negative 3, we get a value of negative 1/3. So negative 3, negative 1/3 is going to be this point here. Negative 2 is going to be negative 1/2. Negative 2 is negative 1/2 here. Negative 1 over 1 is just negative 1. That's this point here. Negative 0.5, 1 over negative 0.5 is negative 2. So when x equals negative half, our y value is negative 2. If we have an x value of negative 0.2, we get a y value of negative 5. So it's going to be way down at this point over here. When we have 0, it's going to give us 1 over 0, which is undefined. And guys, the way that we deal with undefined values on a graph is going to be with this vertical asymptote over here. So this is going to be x equals 0, which is a vertical asymptote. Okay. Now going forward, positive 0.2, we had positive 5, positive 2, all the same values that we had before, except these are now positive values. So 0.2 comma 5 is this point over here. 0.5 comma 2 is here. 2 1/2, 3 1/3, and so forth like this. Now, also we're seeing, guys, hopefully you see that as x starts getting big over here, so if I put an x equals 5, I get a y value of 1/5 over here. If I put an x value of 10, I get 1/10. So hopefully what you're seeing here is as x starts getting huge, bigger this way, this blue graph is going to be approaching this red line over here, but not actually crossing it. So this is going to be y equals 0, which is our horizontal asymptote. All right, so there's going to be a horizontal asymptote for this guy over here. Guys, the shape of this graph, we have kind of a fancy name for it. This is called a hyperbola. Okay, so this is the hyperbola is going to be the type of graph that we have over here. All right, so before we move on here, guys, I'm just going to open up a Desmos file here. Okay, so what we see over here, here's a picture of the graph that we just worked. Okay? So now what I've done over here is I made this guy y equals a, so there's going to be a vertical stretch here, and then an h and k, and there's going to be a horizontal translation over here. You may notice, guys, that I'm not doing a b value, and I'll explain why I'm not doing a b value later, but it has to do with what we call equivalent transformations over here. Okay. So right now, just my a value is 1, my h value is 0, my k value is 0. So just talking about what these different parameters do, okay? Well, my h value is going to switch, it's going to translate my graph left to right, okay? So if h equals negative 8, well, my vertical asymptote is going to be x equals negative 8 over here as well, okay? So this is going to move my horizontal asymptote left to right by switching this h value like this. My k value is going to shift my graph up and down, and it's going to move my horizontal asymptote. Okay, so if I make a k value of 3, it's going to move my horizontal asymptote up to 3, and the graph's going to shift like this. Okay, so the questions you're going to see, guys, we're going to give you a graph, and ask you to kind of determine the equation. Okay, well, you're going to determine your h and your k values based off where your asymptotes are going to be. Okay, so if I'm just looking at this graph over here, I see my asymptotes to x equals 4 over here. That means this h value must have, sorry, this is h equals 5 now. That means my h value must be 5. Okay, the next thing is our A value. Our A value is going to be our vertical stretch, okay? So as this guy keeps moving up and down like this, the graph's going to be stretched this way, okay? Now, one thing that we should know is like if you look at this point over here, if I have an A value of 1, if I look at where the intersection point of my two intersections, my two asymptotes are, here it's 0, 0. If I go over 1, I go 1 up. That's with an A value of 1. If I have an A value of 2, I'm going over 1 up 2. If I have an A value of 3, I'm going over 1 up 3. And guys, that does not matter where the asymptotes are. So if I have these guys as my asymptotes, I find the intersection point over 1 up 3, and that's that this up 3 is my A value over here. Same thing if I go to the left. If I go left 1 and then down 3, that's because of an A value of 3 as well. Okay, so away again, if we're looking at a graph, if you want to determine what the A value is, okay, well, one way is going to be just by plugging in a point. But if you just go from like 1 to the right of your intersection point of your asymptotes, and then kind of count what that vertical distance is going to be there, that's going to be your A value. Okay, so for this example, we just have to sketch a few rational functions over here. So let's go ahead and do that. So we're going to try to do this without a calculator, guys, just so we know how these guys work. All right, so this is telling us that we're translating this guy 3 to the right. So that's going to mean that we have a vertical asymptote here at x equals 3. We're translating this graph 2 up. So that means we're going to have a horizontal asymptote at y equals 2. Okay, now in this case, the A value is 1. So what we're going to do is we're going to start at our intersection point here and go 1 to the right and count 1 up. Same thing if I go the opposite direction. If I go 1 to the left, I'm going to go 1 down over here. Okay, now these points that I've drawn over here, this is really going to be enough. I'm just going to kind of draw the hyperbola now that passes, approaching the asymptotes that goes through this point over here. And the graph will look like this. Okay, so here's a graph for this guy over here. Let's take a look at example B. We're going to go 2 to the left. We're going to go down 4. Okay, now over here, this negative is really saying the same things like negative 1 over x plus 2 minus 4. So this means I have an A value of negative 1. That means I'm going to go starting here at the intersection point, 1 to the right, I'm going to go 1 down. And if I go 1 to the left, I'm going to go 1 up. And this is how this reflected graph is going to look like this. Okay, so we have x equals negative 2 and y equals negative 4. Sorry guys, I didn't finish up the previous example. All right, so what's our domain going to be? Our domain is going to be to the domain of this one. Our domain is going to be all right. Domain goes from negative infinity to negative 2, and then from negative 2 to infinity. So all this is saying is we're excluding the value of negative 2. Okay, so this is how I wrote this guy in interval notation. Same thing for the range. We're going to go from negative infinity to negative 4. and then combine that with from -4 up to positive infinity. This is saying the same thing as we're excluding this guy over here. These are our two asymptotes over here. I'm just going to do the domain for this guy. I'm just going to use set notation, just so we're covering both methods here. So if I'm going to use set notation for this guy, my domain is the set of all x such that x cannot equal 3, but then x is any real number like this. So this is how I'd indicate the domain in set notation. The range in set notation is the set of all y and we have our two asymptotes at x equals 3 and y equals 2. Okay, so similar ideas over here. I'm just going to try to do these ones a bit quicker, guys. We're going to have our asymptote at x equals 3 and at y equals 1. I can do our domain right away. So our domain is going to be x is not equal to 3. Our range is going to be y is not equal to 1. Okay. Now, this a value of 2 means, so this is a equals 2. We're going to go 1 to the right, but now I'm going to go 2 up, like this. And for over here, I'm going to go 1 to the left, and I'm going to go 2 down. Okay. So now I'm just going to do my best to kind of sketch my hyperbola that passes through that point, approaching both asymptotes like this. The graph's going to look something like this. Okay. And I forgot my y equals 1 asymptote. Okay. Now over here, we want to get an equation in this form over here. But what you see is like I have a 2 first and this is minus x. So what I'm going to do is I'm going to factor out a negative out of the denominator in this equation. So h of x equals 3 over negative 2 plus x plus 4. And then I'm going to bring this negative up top and make that a negative 3. I'm just going to rearrange these so it's x minus 2 instead. Okay, so now 2 to the right, up 4. We have an a value of negative 3, so that means if I go 1 to the right, 3 down, 1 to the left, 3 up, and then my asymptote is, or my hyperbola is going to look like this guy, this. Our domain, I'll do this one in interval notation, is from negative infinity to 2, combined with 2 to infinity. Our range is from negative infinity to 4, combined with 4 to infinity. Our asymptotes are x equals 2 and y equals 4. Okay, example 3. So what we have here is we have to write each rational function in the form y equals a over x minus h plus k. Now, I just want to kind of do a separate question over here, guys. If you remember way back to the very beginning of the course, we did a bit of long division, okay? And now, for long division over here, I'm going to say just to do an example with a number. And let's say I have 3 gets divided into, let's say, 205. Okay. Now, the way this works over here, 3 into 205, 3 goes into 20 6 times. 3 times 6 is 18. Subtract, we get a 2. Bring down the 5. 25 divided by 3 is 8. And we had a remainder of 1. Okay. So really what this is saying is 205 divided by 3 is equal to 68 plus 1 over 3. Plus 1 over 3 like this. Okay, so in this case, this was the quotient, and this was the remainder over the divisor. Okay, so we saw expressions like this. To take this equation here, x over x minus 3, and put it into this form. So guys, in this form over here, a has to be a number and x is our variable over here. We have to have this plus k value over here. Well, hopefully what you see, guys, like this is 1 over 3. It's going to be the same thing as this part over this part, and this is going to be the plus k. Is going to be the quotient over here. Okay, so what I'm going to do is this is saying I'm taking x and dividing it by x minus 3. So really I'm saying x divided by x minus 3. Well, how many times is, so what's x divided by x? X divided by x is 1. I'm going to subtract 1 times x is x, and now I'm going to subtract these guys. I get 0 minus 3, like this. Guys, I made a mistake here. I got this division statement backwards. Apologies, guys, sorry. We're going x minus 3 is being divided into x, like this, okay? We're dividing x by this, so that means this guy is going into this guy over here, okay? So x divided by x, so x minus 3 is going to be 1. I'm just going to put a plus 0 here. Now when you subtract these guys, 1 minus 1 is 0. 0 minus negative 3 is 3. So what this answer is going to be is the same thing as 1 plus 3 over x minus 3, like that. Okay, so now this is the form that we're looking for. Okay, so we're going to have 3 in the top, x minus 3. I'm just going to rewrite this guy as y equals 3 over x minus 3 plus 1. Our domain is x cannot equal 3. Our range is y cannot equal 1. Okay, and this is by going, the bottom is being divided into the top over here, and we're going to use long division. Okay, so same thing for over here. I'm going to divide the bottom term, which is x plus 6, is being divided into x, like this. And I'm going to put an x plus 0 here because we're going to need that. X divided by x is 1. 1 times x plus 6 is x plus 6. We subtract. 0 minus 6 is negative 6. So this answer is going to be 1 plus negative 6 over x plus 6, which is the same thing as f of x equals negative 6 over x plus 6 plus 1. Okay, our domain our range okay, guys, this is definitely the newest concept that we're learning in this topic over here, guys, like that. So it's going to need a bit of practice kind of getting good at these ones. All right, same thing over here. So we have a bit more practice doing these over here. We're dividing x plus 2 going into x plus minus 3. So I'm going to go x plus 2. So this is saying x minus 3 is to being divided by x minus 2. So x divided by x is 1. 1 times x plus 2 is x plus 2. We subtract. The x's cancel out. Negative 3 minus 2 is negative 5. So this answer is 1 plus negative 5 over x plus 2. Our domain, so here's no more practice in interval notation. We go up to our asymptotes can be at negative 2, so it means we're excluding negative 2, and this is how we write this with interval notation. And for our range, same idea. Just like that. All right, g of x. Same idea, guys. We're dividing x plus 2, x plus 5 into 2x. Now I'm just going to put 2x plus 0 here just to make it a bit easier. 2x divided by x is 2. We get 2x plus 10. We subtract 2x minus 2x is 0. 0 minus 10 is negative 10. So g of x equals 2 plus negative 10 over x plus 5. I'm just going to rewrite this guy as negative 10 over x plus 5 plus 2. Our domain, our range, and we get this is our answer. All right, guys, I hope this is making a bit more sense over here. Example 4. Okay, I'm just going to do this one in decimals first here, guys. Okay. This is another type of rational function that we're going to study in this unit. Okay, so just the idea of like how this table of values is going to work. If I put in x equals 0.5, well, 0.5 squared is 0.25. 0.21 over 0.25 is going to be 4. So we're getting this point over here, which can be 0.5 comma 4. Okay, 1 over 1 squared is 1. If I put in an x equals 2, 2 squared is 4. 1 over 4 is 0.25. So I'm seeing this point right here. Now, the reason why this graph is going up on the left-hand side as well is because anytime I square a negative x value, it's going to become positive. So that's why we only have positive y values on this graph over here. Okay, so this is what our graph of y equals 1 over x squared looks like. So, like we saw before, if we have, just going to do a quick table of values for this guy. I'm not going to do a table of values for part B, guys, just for part A. But so we have x, y. Let's go negative 0.5, negative 1, negative 2, 0. I'm just going to do this in the up. Sorry, guys. Let me do this again. Negative 2, negative 1, negative 0.5, 0, 0.5, 1, 2. So negative 2 squared is 4. 1 divided by 4, we get 1 quarter. So negative 2, 1 quarter. It's going to be this guy here. Negative 1 squared is 1. 1 divided by 1 is 1. Negative 0.5 squared is 0.25. 1 divided by 0.25 is 4. So at half, we're going to get 4. And we're seeing this curve like this. Okay, we have undefined here, which is going to lead to a vertical asymptote at x equals 0. when y equals 0 0.5, 0 0.5 squared is 0.25. 1 divided by 0.25 is 4. And we get the exact same values here. Exact same y values. Oops, that was at 4, not at 3. 1, 1. And we have this graph that looks like this. Our domain is x cannot equal 0. Our range is y is greater than 0. So we only have positive y values in this graph over here. Okay. So now for part B, same exact thing. We've just been translated 3 to the right and 2 down. So that means our asymptote is going to be here. 2 down like this. And this graph looks like just like this. So our domain, I'll do this one in interval notation. So our range is only going to be from -2 to infinity. So it's going up. Again, guys, we're not including, so we have round brackets on these guys because we're not including this this -2 value. So we're not going to include that one. All right, guys, that is the end of this topic. So this is topic 9.1 in the textbook like that. I hope it makes sense. Please let me know if you have any questions.